Hello students, now in previous video we have been started the coefficient of variation and we have seen some examples on it for discrete frequency distribution, for individual frequency distribution, and for now in this video let us see for continuous frequency distribution how to determine the coefficient of variation. Already we have seen the formulas for that, but now let us see the example and also few more examples on it. So calculate. Example is that calculate coefficient of variation for the following data. Profit in rupees given to us, now rupees in crores, and number of companies. Number of companies means what? The frequency. Number of companies. Now profit in crores is from 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60. This is given, and number of companies having the profit between 10 to 20 crore are 8. These are 12. These are 20, 6 and 4. As such the data is given to us and we have to determine a coefficient of variation for this data. So now solution for this. Now as this is a continuous frequency distribution, our result for, the result for CV is same. The formula for or the CV is what? The standard deviation upon mean into 100. It is given in percentage. And where what is standard deviation here? As it is a continuous frequency distribution. So sigma is what? Summation Fi xi square upon summation Fi, that is capital N, minus x bar square. This is the result for sigma, or that is the standard deviation here. And what is the result for x bar? X bar is what here? Summation Fi xi upon summation Fi. Where this xi is what? Xi is nothing but the class mark, or the midpoint of each of the class is what? A class mark. So now we need these terms, summation Fi xi, summation Fi xi square. So let us form a table for that. We have we have class intervals, so we can determine xi's from them, and we have fi's here. So let us form a table. So profit, so that is what? The class intervals. So let me write here xi means what? The class mark of each class interval, that is the midpoint of each class. Here let us write number of companies means what? This is Fi. So let me write simply Fi here, and I need this product Fi xi its sum and also Fi xi square its sum. So let me write that Fi xi and Fi xi square. Let us find out them so that we can substitute them in a result. So profit is what? Between 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. As such given to us. Xi's are what? 8, 12, 20, 6 and 4. And sorry, these are not xi's. These xi's are what? Our class marks. So xi's are between 10 to 20. The xi is 15. Upper limit plus lower limit upon 2. So 20 plus 10 upon 2 will be 50. Similarly here it will be 25, 35, 45 and 55. And our Fi's are these values, that are 8, 12, 20, 6 and 4. Now let us take this product. This is 120, this is 300, this one is 700, this is 270, and this is what? 220. and FIXI into XI will be FIXI square. So this will be 1800. This is what? 7500. Okay, this is 24,500. This is 12,150 and 12,100. Now we need summation Fi. So let us take this sum. This sum will be 50. That is what? Capital N. Fine. Now this sum also we need summation FIXI. So this sum will be 1610. And this sum is also we required. So this is 58,050. Okay. Once we found all these, so we can substitute them in the result. First of all, find out X bar. Later on, let us go for standard deviation and then for CV. So what is X bar? X bar is summation Fi Xi upon summation Fi. That is arithmetic mean. So here we have the value 1610 upon summation Fi means 50. So our mean will be 32.2. Again, sigma is square root of positive square root of summation Fi Xi square upon summation Fi minus X bar square. Fine. So it will be what? Let us substitute the values. This sum is 58,050 upon this is 50 minus this X bar is 32.2 square. So this simplification will be under root 124.19. So this will be, the square root will be 11.1427. You can do it on calculator also. Verify it. Now what is CV? CV is what? The ratio of percentage of the ratio of standard deviation with arithmetic mean. So standard deviation is 11.1427 upon X bar is 32.2 multiplied by what? 100. So this, what does this answer? This answer will be, this is in percentage and that answer will be 34.6046. These many percentage. This is our CV for this given data and for continuous frequency distribution. Now similarly, let us solve next example in which two different things are given to us and we have to compare them. As I say earlier, the coefficient of variation is used to compare the data, of two different things. So same thing we are doing here now. Let us take the next example. The index number of prices of cotton and coal shares for first 6 months in 2000 were as given below. Now the prices of cotton and coal shares for first 6 months in 2000 are given to us. So month is from January to June. So January, February, March, April, May and June. This is given to us. Okay? Now May and June. So now here for cotton and for coal. For cotton the prices are 188, 178, 173, 164, 172, 184. And for coal it is 131, 130, 130, 129, again 129 and 120 as such given to us. Now what is the question? The question is that which of the shares you consider more variable in price. Now the same question can be asked that which of the shares you consider is less consistent in price. More variable is same as to say less consistent, and less variable is same as to say more consistent. So now solution for this. Now two different things we have to compare here, cotton and coal. So we need to determine the coefficient of variation for cotton as well as the coefficient of variation for coal. Now here this is what? This is individual series distribution is given to us. So let us find out the coefficient of variations for both of them. So actually we can say for comparison of variability, the best measure is what? Is coefficient of variation. So let us determine the coefficient of variation for coal as well as for cotton. So let me prepare a small table first. So month, let us write down for cotton. Let us say cotton, we will denote it by X. We need X square that time. And let us write here coal. Let we determine coal by Y, and we need Y square here. Fine. So month. So January, February, March, April, May and June. These many. So cotton, the prices are 188, 178, 173, 164, 172 and 184. We need X and we need X square to determine standard deviation, and summation Xi we need for determining mean, so that we can determine coefficient of variation. Again for coal it is what? 131, it is 130, again 130, 129, 129 and 120, and these squares also we have to do. So let us write these squares first. So the square I have done is this is 35,344. This is 31,684. This is 29,929. This is 26,896. This is 29,584. This is 33,856. Similarly, these squares are 1700, 161, 16,900, again 16,900. Fine. This is 16,400, 16,641. This is also 16,641, and this is 14,400. Now we need all these sums. So let us determine all the sums. This sum is 1059. This sum is 1,87,293. This sum is 769, and this one 98,643. Now let us determine each one by one. So let me do it comparatively. So let us determine x bar, so comparatively determine for y bar also. Means for, this is for cotton, suppose for cotton, and here suppose for wool. Let us do it. So for cotton, first of all determine mean. Mean means what? X bar, that is summation xi upon n. So what is summation xi here? Summation xi is 1059, and how many observation? It is the data for 6 months, so n will be 6. So it is 1059 upon 6. So mean will be 176.5. This is our mean. Now similarly determine for coal. So here mean is what? Y bar, and that will be summation y upon what? N. What is summation y? Is 769. So it will be how much? 769 upon 6. So that is 128.1667 as such. Now determine here standard deviation, that is sigma x suppose. So it will be square root of summation x square upon n minus x bar square. Here sigma y is what? Summation y square upon n minus y bar square. So let's substitute the values here. What we get? It is 1,87,293 minus, or let me write, upon n. N means what? 6 minus x bar square means what? 176.5 its square. This much. Again, what is it? Here it will be square root of how much? 98,643 upon 6 minus, this is 128.1667 its square. So now this, after simplifying it, we get here the square root will be 7.953, and here it will be 3.7144. Okay, now let us see what is CV then. CV for what? X. Let me say for x. X means for cotton, suppose. So CV for x will be sigma x upon x bar multiplied by 100. So sigma x is 7.953 upon x bar will be 176.5 multiplied by 100. So it will be 4.5059, these many percentage. And here CV for y, that will be sigma y upon y bar multiplied by 100. Sigma y is 3.7144 upon y bar is 128.1667 multiplied by what? 100. So it will be 2.8981. These many percentage. Now here look at the values of CV, that will decide which shares are more variable in price. Fine. So now here CV for cotton is greater than CV for coal. So it shows the shares of cotton are more variable in price. So let me write that here answer. How the answer will be written? We will write since CV for cotton, X means what? Cotton, is greater than CV for what? Coal. That is, what is the values? 4.5059 will be what? Greater than 1, 2.8981. So this says shares shares of cotton are more variable in price. That is less consistent in price. That is are less consistent in price. This can be written. As such, this example can be solved for compare the two different things. Now, similar type of example let me take for the continuous frequency distribution. This is individual frequency distribution. So let us take same comparison type example for continuous frequency distribution also. So now the example says a purchasing agent received sample of envelopes from two suppliers. He had tested the samples for tearing weight with the following result. Okay, find out, the question is that find out which company envelopes are more uniform. So the data tearing weight, this is obviously given in kgs. Then sample from suppliers. Now there are two different suppliers. So supplier A, I can write supplier A and again sample from B. As such the data with us. Fine. What does this? This is 50 to 60, 60 to 70, 70 to 80. These many kgs we will put up in there. 80 to 90. And here the tearing weight will be 3. Here 42, 12 and 3. Here 10, 16, 26 and 8. So now we have to check which one is more uniform. So solution. So here also we will determine coefficient of variation to compare the uniformity of tearing weights. So for supplier A and for supplier B we need to do separate calculation here. So for supplier A, suppose for supplier A, okay. So now for that let us prepare a table. So tearing weight, okay, given is what? Fi, fine. Xi we will determine. We need Fi as we saw in previous example here, Fi square. So here tearing weight 50 to 60, 60 to 70, 70 to 80 and 80 to 90. Okay, FI is what? 3. Okay, wait. Here 3, 42, here 12 and 3. XI is what? Here 55, 65, 75 and 85. The product will be what? 165. Here 2730, 900 and 255. Again FI XI into XI, so that will be 9075, 1,77,450. Here 67,500 and 21,675. So let us do these sums. We need them these much. So this sum will be 60. This sum is 4,050. This is 2,75,700. So now let us determine the CV for this supplier A. So for that we need first X bar. So let me write X bar for A. So it is summation FI XI upon summation FI. So it will be 4,050 upon 60. So it is 67.5. So now standard deviation for A. So it will be square root summation FI XI square minus or upon summation Fi minus what? X bar square. Fine. So it will be root what? 2,75,700 upon 60 minus 67.5 square as such. So simplification of this will give us what? The value is 6.2249. Okay, and therefore what is CV for A? It will be sigma A upon X bar at A multiplied by what? 100. So it will be sigma A. What is sigma A? Sigma A is this 6.2249 upon this 67.5 multiplied by what? 100. So this CV is how much? This answer will be 9.2221. These many percentage. This is the CV for A, for supplier A. Now for supplier B. For supplier B, let us determine that. Again, tiering weight FI, XI, FI, oh sorry, we will say, let us say it as YI or okay, YI, then FIYI and FIYI square. Okay, so now again this is same 50 to 60, 60 to 70, 70 to 80 and 80 to 90. Now FIs are different, so this is 10, 16, 26 and 8. YIs are the midpoints. These are same again 55, 65, 75 and 85. Okay, take the product. This is 550, this is 1040, this is 1950, this is 680, this is 30,250, this is 67,600, 1,46,250, this is 57,800. Now this sum, this and this one we need. So this summation will be 60. Here 4220. Okay. Here it will be 3,01,900. Fine. Now again determine the same CV for B. So X bar for B will be summation FYYI upon summation FI. So it will be what? Summation FYYI is 4220 upon 60. So this will be 70.3333. And sigma B equal to root summation FIYI square minus summation FI minus Y bar square. So it will be root what? This is 3,01,900 upon 60 minus 70.3333 its square. So this simplification will be, this is 9.2138. Fine. And now CV for B. What is CV for B? CV for B will be again sigma B upon X bar for B into what? 100. Fine. So it will be 9.2138 upon 70.3333 multiply by what? 100. So the answer will be 13.1002, this much percentage. Now CV for A will be 9.2221, here 13.1002. Here this is 9.2221. This is, be careful for this. This is 13.1002. This much percentage. This many percentage. Fine. These are the values here. Fine. So CV for A is less than CV for B. So the company A's envelope are more uniform than the company B's envelope. These are more uniform, as this CV is less. So finally, how to write the answer? Let us write down the answer here. Since CV for A, that is 9.2221%, is less than CV for B, that is what? 13.1002%. Therefore, company A's envelopes are more uniform than company B's envelopes. Okay, now here we will stop. Now while completing, let me give one small example as an homework to you. You can do on your own for that. So a very simple example I am giving as a homework, that only one I am giving, I won't give more. Find the standard deviation. Find the standard deviation of first 10 natural numbers. Now this is very easy question. Now first 10 natural number means 1, 2. So this is individual series distribution, so you can use that formula and determine the standard deviation. Okay, if you have any doubt in this, ask me either on Google Classroom or WhatsApp group. Now in next video also we have to see some more examples on the combined standard deviation and the combined CVL also, how does it changes. Okay, thank you.